Today I am going to discuss about angular momentum. I shall discuss the importance of angular momentum in real life also. Now what is angular momentum? Angular momentum is rotational equivalent of linear momentum. Angular momentum of a particle about any fixed point is defined as L equal to r cross p, where r is the position vector of the particle from the point and p is the linear momentum. So as L equal to r cross p, so L is perpendicular to both r and v, that is p. So L equal to r cross mv. As angular momentum is r cross momentum, so it is also called moment of momentum. Conservation of angular momentum makes it very important in physics. So what is conservation of angular momentum? Total angular momentum vector of a particle remains constant in time if the total external torque acting on the particle is zero. This is the principle of conservation of angular momentum. That is L equal to constant. A good example of this law is a planet moving around the sun. For example, the Earth's orbital angular momentum L equal to mvr equal to m omega r square. Actually, Earth moves around the sun in elliptical orbit, but now I will take the average case. So the average distance between Earth and Sun is r, which is 15 into 10 to the power 10 meter. Mass of Earth m equal to 6 into 10 to the power 24 kg. And average velocity of Earth is 30,000 meter per second. So L equal to mvr, that is 2.7 into 10 to the power 40 kg meter square per second, which is equal to constant. Let's understand the concept of angular momentum by means of area of a parallelogram. Suppose blue point be any point in space and the red object which is of mass m moves to the right. The blue arrow indicates the position vector and red arrow indicates the velocity vector. From the definition of angular momentum L equal to r cross p, we can say magnitude of L is nothing but equal to area of parallelogram whose sides are r and p, that is mv. So L equal to mv r sin x, where x is the angle between r and p. Now from conservation of angular momentum, we can say at time t equal to t1 area of parallelogram equal to area of parallelogram at time t equal to t2. Now let's understand the concept of conservation of angular momentum by another example. When two balls move around each other in a circular path, their angular momentum is constant. That is L equal to mvr equal to m omega r square. When distance between them increases, that is r increases, they move slower, that is angular velocity decreases. But when the distance between them decreases, their angular velocity increases and they move faster. Now let's understand conservation of angular momentum by an interesting example. Suppose if a man stands on a turntable with weights extended, his overall rotational inertia is relatively large in this position. As it turns slowly, his angular momentum is L equal to I omega. I is the momentum inertia of that body and omega is the angular velocity. the weights inward, his overall rotational inertia is decreased and his angular velocity is increased. So, if you stand on a turntable, it may be a trouble to you then. So, at the conclusion, we can say whenever a rotating body contracts, its rotational speed increases. So guys, end of the chapter. If you like the video, like, comment, share and subscribe to my channel. Bye.